Very good morning to one and all, and I welcome you all for the next lecture of Production Operation Management. Kindly let me know whether my voice is audible and can you see my presentation?
Yes, sir.
Great. So in the last lecture, we have discussed two problems on least square method, and we can say that the regression analysis type of a method. So today, also we have taken the overview of problem number 3. What is the trick in problem number 3, or what is the difference of this problem from previous two problem? Okay, how it is differ from previous two problem, that we have discussed in the last lecture. I hope some of the students have solved this problem at their home as a homework. But if you are not getting the proper idea of a problem, I will explain once again, and we will go thoroughly through this particular problem. Okay, so problem statement is: the sales for the domestic water pump manufactured by Ajit Manufacturing Company is given. Forecast the demand for the pump for next 3 years using the least square method. Okay, so this was the problem, right? This was the problem. Okay, and the data is provided in the years. Okay, so for particular year, what will be the sale, what was the sale, that data is provided, and this sale in a 1,000 quantity. Okay, so triple zeros are provided, that is nothing but a 1,000 quantity. So 30,000, 33,000, 37,000, so in this fashion. So for 1986, 30, 1987, 33, for 88 year, 37, 89, 39, 90, 42, 91, 46, 92, 48, 93, 50, 94, 55, and 95, 58. So I hope you have written this problem statement and the given data. Okay, if not, you can write this also. Okay, so years are provided. And the cell is provided to you for the years from 1986 to 1995. Okay, now what is the problem here, what is the difference of a problem, how it different from previous two problem? So that is nothing but previous two problems are having the data of odd numbers. Okay, total number of data is equal to odd number. Okay, so that in that case it will be easy to calculate the deviation, or to determine the middle period, to consider the deviation equal to 0. Okay, but in this case the total number of periods are given as 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So data given is even number. Okay, total number of data is even number. Okay, so in that case, which period we should consider as a origin of a deviation? Okay, that is the trick. Okay, which period we need to consider as a origin for a deviation? That is the trick in this particular problem. Okay, and for that purpose, first of all, we have to consider the middle two period. Okay, not a single period will be considered as a middle period. Okay, two periods will be considered as a middle period. Okay, so now here 1990 year and 1991 year are the two middle periods, because on one side of that 1990 the 4 periods are provided. Okay, 1, 2, 3, 4, and on another side of 1991 4 periods are provided, that is 92, 93, 94, and 95. So 1990 and 1991, these 2 years are considered to be a middle period. Okay, then also the problem is not solved. ओके. नाव मिडवे पिरियड. ओके, ह्या दोघांच्या मधला पिरियड 1990 आणि 1991, ह्या दोन इयर मधला पिरियड, ओके, जो काही काळ असेल, ह्या दोघांमधला जो काही काळ असेल, त्या दोघांमधला मध्ये एक कुठला तरी काळ असेल, ओके, त्या दोघांचा सेंटर येणारा, तर तो पॉइंट किंवा तो पिरियड आपण मिडल पिरियड कन्सिडर करणार आहे. ओके ओके. नाव while providing the deviation, the midway period between 1990 and 1991, we have to provide the zero deviation, or we have to consider the origin of a deviation. We have to consider the origin of a deviation, and from that point we have to start giving the deviation. Okay, so that is the trick. Okay, so as the number of periods is even, sum of the deviations is made equal to 0 by making midway period between two middle period is made as origin. Okay, is made as origin. Now how it will be happen? Now consider, as our problem is that 1990 and 91, these two periods are the middle periods, okay, for the data. Now this in between these two period, okay, 1990 and 1991, whatever the period is there, okay, so that will be considered as the origin for the deviation. So we have to provide the zero deviation. Okay, now positive half deviation we have to provide for the 1991 year. Okay, positive half deviation we have to provide for the 1991 year, because it is the preceding year or preceding period from the origin. Okay, from the origin. And the for the previous year, okay, for the 1990 year, which is a previous period from the origin, and for that previous period we have to provide the negative deviation. Okay, we have to provide the negative deviation, and it should be equal to minus 0.5. Okay, and further things we need to apply as it is. Okay, accordingly we have to add up the +1 deviation for the preceding periods and -1 deviation for the previous periods. Okay, so in this fashion we will provide the deviations. Okay, so as we have discussed the procedure for the calculation purpose, we have to formulate the table having the serial number, years, cells or a demand, deviation square, that is x square, and deviation multiplied by demand or a cell, that is x multiplied by y. Now provide the serial number and years and cells data as provided given data in the problem statement. Okay, in that particular table. So first period is 1986, cell is 30. Second period is 1987, cell is 33. Third period is 1988, cell is 37. Fourth period is 1989, cell is 39. Fifth period is 1990, cell is 42. Sixth period is 1991, cell is 46. Okay. Seventh period is 1992, cell is 48. Eighth period is 1993, cell is 50. Ninth period is 1994, cell is 55. And 10th period is 1995, cell is 58. Okay. Now how many total number of periods? Okay, that will come to know from the serial numbers. That is, total 10 periods are there, or 10 number of years data is provided to you, so that n will be equal to 10. Okay, so that should be written at the bottom side. Okay, n is equal to 10, that should be written at the bottom side. So summation of y, we have to calculate the summation of y. So summation of y means sum of the cells demand or sum of the cells. Okay, so in that case you have to add up this all the cell values. Okay, all the cell values. Okay, do calculation and kindly let me know what is the value for the summation of y. Actually, I'm not having the values. Kindly check the values. We can put up in chat box also. Yes. Do the calculation, everyone, and put up the summation of y in the chat box. 439 or 438? Which one is right? 439 or 438? Whether my voice is audible?
Yes, sir.
Yeah. So keep your calci with you while attending the lectures. We are the engineers, not a BA BCom student. Our main instrument is our calci. Okay, that should be with you while attending any lectures, because at any time you need a calculator for the calculation purpose. So don't use mobile calculator, that will not help you. Okay, and it will not be that much handy to do to perform the engineering calculations. So use scientific calci. Okay, now next, as we have calculated the cells, kindly 438, right? Okay, thank you for confirmation. 438 answer is right one. Now next is important part, we have to provide the deviation. Okay, so once again I'm saying that I have written in the last lecture only. So if you forgot how to provide the deviation, I will repeat it. Okay, so now here middle years, two middle years we have to consider in case of even number of periods. Okay, even number of periods. So fifth number and sixth number period is the middle two periods in case of a even number periods. Okay, total number of periods are 10, so these are the even number problem. So in that case we have to consider the two middle periods. So fifth and sixth period, that is 1990 and 1991 years, are the two middle periods in this case. Now midway period, okay, जो काही 1990 आणि 1991 ह्यांच्या दोघांच्या मधला जो काही काळ असेल त्याला आपण ओरिजिन कन्सिडर करणार आहे डेव्हिएशन साठी. मग ओरिजिन नंतरचा जो पिरियड असेल 1991, तो हाफ मिळाला आपल्याला. मिडलला घेतल्यानंतर ह्याच्या नंतरचा जो डेव्हिएशन घ्यायचा असेल 1991 साठी, तर ते तुम्हाला हाफ मिळणार आहे, म्हणून इथं प्लस 0.5 तुमचं डेव्हिएशन असणार आहे. सिमिलरली आता अपोजिट साइडला आपल्याला निगेटिव्ह डेव्हिएशन द्यायचं आहे. ओके, आणि ते पण हाफ असणार आहे इथून ह्या दोघांच्या मधल्या काळापासून 1990 पर्यंत. तर हे पण आपल्याला हाफ घ्यावं लागणार आहे. मग ते डेव्हिएशन किती असणार आहे? -0.5. Okay, so then further you have to provide the deviation by adding +1 on either of the side. Okay, so for 1992 year we can provide the deviation as 1.5. Okay, by adding 1. For 93, 2.5, right? For 94, 3.5, and for 95, 4.5. Okay, and in the opposite side you have to add -1 on each period. Okay, so -0.5 plus -1 is nothing but -1.5, -2.5, -3.5, -4.5. Okay, so if you add up all these quantities, okay, -4.5, -3.5, -2.5, -1.5, -0.5, plus 0.5, plus 1.5, plus 2.5, plus 3.5, plus 4.5. So that addition will be considered as summation of x, and that will be equal to 0. That will be equal to 0. Now further, we need to take the square of a deviation. That is nothing but 4.5 square. The square of 4.5 is 20.25. Then 3.5 square is 12.25. Then 2.5 square is 6.25. If I am wrong, please correct me. Okay. 1.5 square is 2.25 minus 0.5 square is 0.25. Same quantities will be repeated on the downward side also. 0.25, 2.25, 6.25, 12.25, and 20.25. 20.25. Okay. And at the bottom, you have to add up all the squares, and that will give you summation of x square. Okay. At the bottom side, you have to make the summation of all the x squares that we have calculated, and you will get the summation of x square. Kindly let me know the value of summation of x square.
82.5.
82.5. Great. 82.5 is the right value for summation of x square. Now further, you required x multiplied by y. So where x is the deviation and y is the cells. So third column multiply by fourth column. 30 multiplied by minus 4.5. You have to write this calculation over here. Then 33 multiplied by minus 3.5. You have to write the calculation over here. Then 37 multiplied by minus 2.5. You have to write the calculation over here. And at the bottom, you have to make the summation of all the x multiplied by y's. So that will provide you summation of x multiplied by y. Okay. So 30 multiplied by minus 4.5 is minus 135, right? 33 multiplied by minus 3.5 minus 115.5. Do calculation, everyone, because if you make any mistake in one of the calculation, then your entire problem will get wrong. Okay, you will get wrong answer. If you made one of the mistake in any of the thing out of this particular table, then your calculation will be wrong, and you will not get the accurate answer. So do calculation rigorously and should have a hands-on calc. 37 point minus 2.5 minus 92.5. Okay. Then 39 multiplied by minus 1.5 minus 58.5. Okay. Please cross check. I may be wrong. So you have to cross check that, and then you have to write that. 42 multiplied by minus 0.5 minus 21. 46 multiplied by 0.5 minus 4 plus, it is plus value, plus 23. 48 multiplied by 1.5, it is 72. 50 multiplied by 2.5 is 125. 55 multiplied by 3.5, it is 192.5. And 58 multiplied by 4.5, it is 261. Okay. So in this fashion, you have to write all the multiplications, and at the bottom, you have to perform the addition of all the multiplications. Okay. So kindly tell me the summation of x multiplied by y. Summation of x multiplied by y. You can use the chat box, or you can switch on your mics and you can tell. No issue. But don't be idle. Okay. Yasar is saying 251. Any another opinion? Yes, no, anything? 251. Okay. Okay, 251. I will write 251 over here as there is no another opinion. Next, we have to calculate A and B, which are the unknown constants in the equation of in line straight line equation. Okay, so when we are getting this A and B values as the equation as summation of y divided by n and summation of x multiplied by y divided by summation of x square, when we are going to put up summation of x is equal to 0 in normal equations. Which are the normal two equations? Summation of y is equal to a plus b multiplied by summation of x. This is n multiplied by a plus b multiplied by summation of x. This is the first normal equation. And second normal equation is summation of x multiplied by y is equal to a multiplied by summation of x plus b multiplied by summation of x square. So these are the two normal equations, and in that two normal equation, when we are going to put up summation of x is equal to 0, at that time we will get a is equal to summation of y divided by n and b is equal to summation of x multiplied by y whole divided by summation of x square. Just put up the values whatever we are getting through the after calculation or after formulating this table. Summation of y is 438. Okay, and n is 10, right? N is 10. Calculate a value, and b is nothing but summation of x multiplied by y. Summation of x multiplied by y is 251, and summation of x square is 82.5. Okay, 82.5. So do calculation and determine the values. Okay, a and b values. Kindly let me know the a and b values. Okay, A is 43.8 and B is 3.04. Akash Mane is saying. Okay, any another opinion? 43.8 A and B is 3.4. Okay, is there any another opinion, or you are getting the same values for A and B? Okay, if you are getting the same values, then we can write the straight line equation. Oh, okay, our straight line equation is y is equal to a plus b multiplied by x. Okay, y is equal to a plus b multiplied by x. This is our straight line equation, and in that straight line equation we have calculated the constants a and b. Okay, so a is 43.8 and b is 3.4. b is 3.4. Okay, now this is our straight line equation. Okay, this is our straight line equation. So I will write here the straight line equation. Okay, straight line equation, y is equal to a plus b multiplied by x, and we will get, after putting the a and b in the straight line equation, y is equal to 43.8 plus 3.4 multiplied by x. Now, what is our question actually? That we need to see. So question is, we have to calculate the demand for the pump for the next for the pump demand for the pump for next 3 years. Okay, so this is our question. So we required what we required? We required the deviation for next 3 years. What will be the deviation for 95 year 1995 year? We got the deviation as 4.5. So for 1996 year, the deviation should be 5.5. 97 year, the deviation should be 6.5. And for 1998 year, the deviation should be 7.5. So that should be our deviation for the next 3 years. And that is the required thing to calculate the forecasting for the next 3 year. Okay. So I will consider for 1996 year, deviation x is equal to 5.5, right? So we can calculate demand for, by using this straight line equation, we can calculate, I will say y96. Okay, demand for 96 year. So here in this equation, we have to replace this x by 5.5, and you just find out the y96. Similarly, you can calculate for 97. Okay, 97. Okay, here x should be 6.5. Okay, and equation should be y97 43 is equal to 43.8 plus 3.4 multiplied by 6.5 for 97 year. And for 98 year, 1998 year, the demand should be, first of all, we need to consider 1998 x should be 7.5. Okay, and y98 should be equal to 43.8 plus 3.4 multiplied by 7.5 Okay, do calculation for 3 years and let me know your answers in the chat box. So value should be in 1,000. Okay, you have to multiply whatever the answer you are getting, you have to multiply with 1,000 to that answer and you'll get the complete value, actual cells. Okay, because the given data is provided in 1,000, 000. Okay, yeah, sir is saying 3.042. Value should be 3.042. Okay, you can take this, no issue. 3.04.
अगं तेल चटणी नाही आहे काही पाणी.
Hello, who is this? Yes, now it is audible. Sorry, I muted myself also. Kindly let me know Y96 and Y97 values. So 96, Yasar told me, or he has put it this value in the chat box, that is 60531. Kindly check this value is correct or wrong. Then also calculate Y97, whether this 63560 is the right value or you have another opinion about this. Once let me know whether I am audible.
Yes, sir.
Yeah. Y97 and 98. 66600. Whether you are getting the same values, kindly let me know. I hope you are doing the calculation. If not, then you can write down the values and do it afterward. Y97 63573 63573 and Y97 y98 66615. Okay, 66615. Okay, no issue. So these are your answers, y96, y97, and y98 for the problem. Okay, getting everyone? I hope you have noted down all the points and this complete problem so that you will come to know the variety of a problem. Okay, so we'll move for the next variety of a problem. Okay, so another type is when the deviation is not equal to 0. Now in previous three problems, what we have done, we have made the deviation is equal to 0. Okay, by considering the origin of a deviation at the middle of the series, but in some cases, where the population included or the data is not according to the sequence. Okay, so in such a cases we are unable to make the deviation equal to 0. Okay, we are unable to make the deviations are equal to 0. We can provide the deviation once we will get the data in a sequential format. Let us say for 91 year, 92 year, it is a sequential data. 93 year, 94 year, sequential data we are getting. But there is a difference between two period is equal to 1. Okay, 96 and 97. What is how much difference? 1 year difference is there. So whenever the difference is constant and the sequential data is provided, so we can easily solve these types of problems by using the previous three methods. But when the problem is related to the scattered data, okay, or we can say that there is no any correlationship between or there is no any sequencing in between the two data which are provided to you. Okay, in that case we are unable to make the deviation of the data equal to 0. So in that case the values of constants can be determined by using the two formulas. Okay, which are that two formulas? So obviously I'm saying about the straight line equation. Okay, in straight line equation, values of two constant, that is nothing but a and b values, can be determined by using the two equations. Which are that two equation? So first one is a. For a we can use the equation, you can note down a is equal to summation of y multiplied by summation of x square minus summation of x multiplied by summation of x multiplied by y whole divided by n multiplied by summation of x square minus inside a bracket x summation of x inside a bracket summation of x bracket square inside a bracket summation of x bracket square. Okay, and b can be determined, value of b can be determined using the formula b is equal to n multiply by summation of x multiply by y bracket complete minus inside the bracket summation of x multiply by summation of y bracket complete whole divided by n multiply by summation of x square minus inside bracket summation of x bracket square. Okay, I'm saying bracket square. So there is a difference between summation of x square and summation of x bracket square. There is a difference between summation of x square and summation of x bracket square. In that case, in summation of x square case, we are first of all taking the deviation square and then making the summation of that is nothing but summation of x square. But in this case we are taking the summation of a deviation only. Okay, and we are taking the bracket square of that. Okay, we are taking the bracket square of that. So this is the difference between summation of x square and summation of x bracket square. Okay, summation of x bracket square. Now these two values or these two equation can be determined formulas can be determined, or these two values alternatively we can determine by using our normal equations, that is nothing but summation of y is equal to n multiplied by a plus b multiplied by summation of x. That is our first normal equation. And another equation is summation of x multiplied by y is equal to a multiplied by summation of x plus b multiplied by summation of x square. So we can formulate this a and b by using these two equations. So we will not go for the derivation part. Directly we can remember these two values or these two equation for a and b, that is as provided over here. And we can use this equation whenever the data is not properly sequencing type of a data, or there is no any correlation, or there is the scattered type of data is provided to you. So in that case, we can use this two equations to determine the a and b values. Okay, so you can write least square method when the sum of the deviation is not zero. Okay, least square method when the sum of the deviation is not zero. Least square method when the sum of the deviations is not zero. Sum of the deviation is not zero. So you can write for the straight line, for the straight line, for the straight line, for the straight line, inside bracket, y is equal to a plus bx, y is equal to a plus bx, bracket complete, comma, the constants can be calculated, the constants can be calculated from the expression, the constants can be calculated from the expression. Write down these two expression for a and b, write it down properly, provide the brackets as and when required, so that it will clarify your doubts. Because if you forgot the bracket over here, okay, over here in this case, okay, in the denominator side, if you forgot the bracket, then it will become summation of x square. Okay, then it will become summation of x square. So that should not be the case. It is summation of x bracket square. Next, you can write alternatively the values of a, the values of, I will say, values of a and b, the values of a and b can be computed, the values of a and b can be computed by solving the following two equations, by solving following two equations. So which are two equations? Normal equations, our normal equations. So summation of y is equal to n multiplied by a plus b multiplied by summation of x, and second one is summation of x multiplied by y is equal to a multiplied by summation of x plus b multiplied by summation of x square. Why we are doing this? Remember point. Why we are doing this? Why we are going for this a and b formula? Because we are unable to make the deviation equal to zero. If it is possible to make this deviation is equal to zero, that is summation of x is equal to zero, then it will be easily determined a and b values by previous method. That is nothing but a is equal to summation of y divided by n, that two formulas. Okay, and b is equal to summation of x multiplied by y divided by summation of x square. But here the problem statement in such a manner that we are unable to make the deviation is equal to 0, so that we are going for these formulas, A and B formulas. Okay, and how we have determined these formulas, or how we reach to these formulas? By using these two equations. Okay, so I will not go in the deep, and it is not a part of our study that how we have we reach to this A and B values. But remember, it will be easy to remember the things. Okay, the numerator is same for A and B. The denominator is same for A and B. The numerator is only differ. Okay, so that much you have to remember. Okay, now I hope you have written up to this point. Okay, shall I take one problem quickly? I will provide the theme of the problem. Okay, and then it will be easy to solve. Okay, so what type of a problem will comes under this deviation is equal to 0? That idea will come to you. Okay, so problem statement, you can write the problem statement. Problem number 4. Problem number 4. A company manufacturing washing machines. The company manufacturing washing machines. The company manufacturing washing machines establishes a fact that establishes a fact that establishes a fact that there is there is there is relationship there is a relationship between there is a relationship between sale of washing machines. There is a relationship between sale of washing machine and population of the city. Okay, there is a relationship between sale of washing machine and population of the city. And population of the city. Okay, and population of the city. The market research carried out reveals the following information. The market research carried out reveals the following information. Fit a line, fit a linear regression equation. Fit a linear regression equation and estimate demand for washing machine. Fit a linear regression equation and estimate a demand for washing machine for a city with a population of 45 million. With a population of 45 million. With a population of 45 million. Okay, so now this is the population and washing machine cell relationship. Okay, we have to establish the relationship between the company come to know that there is a relationship between washing machine and the population of that particular city. Okay, number of population is correlated to the number of cells in that particular city, number of cell of washing machine in that particular city, and data provided to you. Okay, in this type of a data is provided to you, that is nothing but population is provided and a number of washing machine demanded in a 1,000 quantity, 28,000, 40,000, 65,000 in that format, because here the cell is provided with a 000. Okay, that is nothing but 28 multiplied by 1,000. Okay, so population, it is provided in a million. Okay, so 5 million, 7 million, 15 million. Okay, so when the population of a city is 5 million, in that case the sale of washing machine is 28,000. Okay, and when population of a city is 7 million, in that case the sale or the demand of a washing machine is 40,000. When the washing machine the population is 15 million, in that case the demand of a washing machine equal to 65,000. When the population 22 million, then the demand of washing machine is 80,000. When the population is 27 million, in that case, the demand of a washing machine equal to 96,000. When the population equal to 36 million, in that case, the demand is equal to 130,000 washing machine. Okay, so that data is provided. Now, whether the data is a sequencing manner, whether we can establish the relationship between these populations, okay, whether it is having the properly sequencing and the difference is constant one? No. Okay, so there is no proper sequencing, there is no proper differentiation between the two datas. Okay, so here we cannot make the deviation equal to 0. Okay, in this case we cannot make the deviation equal to 0. So what, first of all, we have to decide what is the deviation in this particular problem and what is the cell demand in this particular problem. Okay, and accordingly we have to provide the nomenclature. Okay, so demand is always y. Okay, in line equation, demand is always represented by y variable. Okay, y is equal to a plus bx. In that line equation, y represent the demand, okay, or the cell quantity. Okay, so number of washing machines demanded, that should be equal to, or that should be considered as a y factor or y variable. Okay, in our table. Okay, and the population, it is 5, 7, 15, 22, 27, 36. This population should be considered as the deviation. The population should be considered as the deviation. Okay, here we are unable to make the deviation is equal to 0. So whatever the population is provided or the data is provided to you for the relation for the demand, that data should be considered as a deviation. So our x values should be 5, 7, 15, 22, 27, 36. Okay, in this manner. So population is a deviation and that should be represented in the x column, and number of washing machine, that is the demand, that should be represented in a y column. Okay, getting up to this, then we can formulate the table. Okay, population x. So you can put up the population values in this x column 5, 7, 15, 22. So I will write here. So you can formulate the table: serial number, population, number of washing machine demanded, x square, and x multiplied by y. So x square is the deviation square, and x multiplied by y is nothing but deviation multiplied by population. I will write here in the bracket deviation. Deviation. Okay, x multiplied by y, deviation multiplied by demand. Okay, so put up the data. I hope you have written up to this 528. 528. Okay, then next 740. 740. Then 1565. 1565. Okay, then next 2280. 2280. Then next 2796. 2796. And 36130. 36130. Okay, now serials, total number of serials, total number of data is provided to you. It is equal to 6. That will come to know from the serial numbers, and therefore your n value will be equal to 6. Okay, then population addition, that is nothing but summation of x. Okay, that you have to write over here. Then number of washing machines, that you can write the summation of y at the bottom side. Then you have to take the x square, that is the deviation square. So 5 square you can write here, 7 square you can write here, 15 square you can write here, 22 square you can write here. And finally you have to make the multiplication of a deviation and the demand, and you have to write that multiplication over here, and at the bottom you can make it summation. Now, we are getting n summation of x, summation of y, summation of x square, summation of x multiplied by y. Then we can calculate a and b values by using the previous two formulas that we have considered for a and b when the deviation is not equal to 0. Okay, by using that two formulas, we can determine a and b values, and we can once we will get the a and b values, we can formulate our straight line equation, and in that straight line equation we can put up the deviation, next deviation x is equal to 45, and we can solve that particular problem. Okay, so in this fashion we have to solve the problem of a population when we have to solve the problems of a least square method when the deviation is not equal to 0. When the deviation is not equal to 0. Is there any doubt, any question in this problem? Kindly let me know. Is there any doubt, any question? You can also solve this problem. You can try at your home, and I request everyone, don't forget to attend the chapter test number 1. That will be the part of your curriculum, and it will be considered for your final submission also. So attend the quiz that I have shared yesterday in the afternoon also, and in the night also. Okay, so only 12 students I have attended that test. Other students, when you are getting time in your busy schedule, attend the quiz. Okay, after your academic schedule you can attend that particular quiz. So if you don't have any doubt, any question, you can put up your roll numbers in the chat box, and you can leave this meeting and join the next lecture. And now today I am seeing good attendance, the effect of yesterday's phone call. 58 students today attending. Let us see how much days they'll proceed with the same sincerity. Saurabh Nikam is also attending today. Madan Patil is also attending. Dhaneshwar Siddole. Many students are attending today. Fastly leave this meeting after putting your roll numbers in the chat box and join the next lecture immediately. कशाचे आज करायचं आहे रिकरिंग आहे नाही कंटिन्युअस पूर्ण डे मध्ये करावं लागेल एकच मिनिट फक्त स्टॉप आणि स्टार्ट रेकॉर्डिंग ठेवायचं roll number 74, leave this meeting, join next lecture. 10, leave this meeting. 11, leave this meeting. 28, leave this meeting. 15, leave this meeting. Roll number 4, leave this meeting.